In today's episode of Hangar DX, we're going to talk to charity majors working on Honeycomb. And I'm really excited for this conversation. Charity has been a very popular celebrity I've been trying to get for some time, definitely popular on Twitter. And we're going to talk about fearless deployments today. But before we get started, Charity, please introduce yourself for the audience here.
My name is Charity Majors. I actually almost never do Twitter anymore, but I have been trying Blue Sky lately, skeeting as the kids say, and I am at charity.wtf there. That's also my blog, and I am the co-founder and CTO of honeycomb.io.
Amazing. Okay, so Charity, you've talked a lot about emotional side of software engineering. You've talked a lot about cultural side of software engineering. Obviously, like, we have also talked a lot about observability as part of Honeycomb. But I am particularly curious about deployments because this is also very close to a bunch of things we do at Aviator. I have written a blog post myself about like fear of deployments. More specifically, let's talk first about like what is like the cultural aspect of deployment, right? Like, how does an engineering organization think about deployments, and where does that fear even originate?
I have a sticker that says the fear of deployment is the largest source of technical debt in almost every organization. And it's not deployments, it's fear of deployment. And it's the anti-patterns that get built up around that and wrap around that. Where does the fear come from? It comes from breaking things. It comes from, shipping code and then the pit of your stomach falling out as you watch all of the numbers go red and everybody in the office turns to look at you. Like this stuff, it builds scar tissue. If you like, I come from the ops side of software, and for years, for decades, the operations profession was in this hunched down state of just like, readiness, fear, like cross swords, thou shalt not pass, we protected production, with our lifeblood and like, don't touch it. That's, and it's been this process of sort of like getting out of that crouch state, and building technical stacks, tools that are more resilient, that are safer, that are faster, that are more friendly, thinking of production less as like your glass castle, and more of like a playground that where everyone, because what we've found is, these software socio-technical systems, they're so complex, right? But the beating heart, they're made of feedback loops on top of feedback loops on top of feedback loops. But like the beating heart of every technology company is getting code from the person who wrote it to the people who are using it, right? And that interval, it's magic, right? Like, I think we can all get so distracted by so many things that are slow or flaky or bad or wrong. But like, anytime I'm talking to an engineering leader who just seems underwater, you start there. How long does it take you to ship a single line of code? Because you can infer so much about an organization from the answer to that question.
Interesting. So software come in many different shapes and sizes. I was also talking to Brian Finster, also a person who talks a lot
Love
about
him.
deployments. Like, the most interesting part of the conversation was he was talking about deployments to submarines, right? I mean, that's, I feel like, almost an opposite end of it, right?
Yeah.
I think generally when we think about software deployment, we are thinking about cloud deployments,
Mm-hmm.
right? Now, if there are many different shapes and sizes,
Yes.
does the process and the mindset changes?
Oh, of course. Absolutely. I think you're right to call that out. There is this tendency for us to, talk about, like we're all shipping web apps, right? And that's not true. And different situations they call for different, they have different dependencies, right? You don't want people to be shipping fast and close to right when they're shipping to a nuclear submarine. Like, you want a different culture, you want a different tool set, you want a different, but I think the principles, like, and I think most of us might not ship to nuclear, any of the submarines in our lives, but a lot of us who consider ourselves general software engineers will find ourselves engaging with mobile devices at some point. And thanks to our overlords at Apple and Google, you can't do continuous delivery to mobile devices, right? And so, like, there are ways, but I think that what you can do is you can keep in mind some of these principles and use them to inform the specific situation that you're trying to solve for. And so, like, mobile developers might not be able to continuously deploy to devices, but what they can do is they can set up a sort of CI/CD thing that gets the mobile app from the IDE through running tests and to a place that you can download things internally. You can use an internal version of that, because, like, it's not actually like, oh, well, if you aren't getting it from your IDE to God's ear in 30 seconds, you're a bad developer. That's not it. The principle is that a lot of this is about cognitive carrying costs, right? And trying to keep that interval short between when you're writing the thing, and it's all, in theory, to when you're actually using it, so that you can look at that, so you can use it, and you will never know more about the change than you do right in that moment. You know what you're trying to do, how you did it, what you tried, what worked, what didn't, what the variables are called, what the functions are, what it's calling. And when you have all that in your head, if you could close the loop by, is it doing what I expect it to do? Does anything else look weird? It's like that is your best chance of finding the problems in your code. If you don't find it in that moment, it's probably not going to be you who finds it. It's probably going to be a user or someone weeks, months, years down the line, right? That is your best chance. And by not making that loop tight, if there's so much time elapses between when you're developing and when you go and you validate it that you have forgotten. And it doesn't take long. It takes maybe a couple hours. You swap in and out another project, and you're like, what
Right.
it doesn't last long. And so keeping that cognitive carrying load, keeping it in a short enough interval that you can check yourself is magic.
Very interesting. So kind of like also alludes to one of the things you talk about, which is shipping should be boring. Do you want to expand a little bit more on that?
Yes. I've gotten many rounds with folks on Twitter about this. And again, I'm not actually a super ideologue, but like, if I was to give folks one recommendation, it's that it's not about, saying people shouldn't deploy on Fridays. It's not actually about Fridays. What it is about is that when you merge your code, you should have an expectation that it's going out immediately, right? You merge your code. It should happen by default. It shouldn't be something that only happens rarely once in a while. It should be, I'm merging my code. That means it's in production, right? It should be, there's this great saying that I think it was Intercom that came up with it. Shipping is the heartbeat of your company. It should be regular. It should happen consistent. It should be boring. It should be expected. It should happen so often that it's just the normal state of things. That is actually the safest state for any company to be in.
Interesting. Yeah, it kind of like also goes to, there's another saying that if it hurts you, do it more often.
Exactly. I will say the single best line of code I ever wrote was actually a bash script. It was two months or so after starting Honeycomb. I got really annoyed with trying to type deploy all the time. And so I wrote a little cron job, shipped it everywhere, so that once an hour, it would check to see if a new artifact had been built. And if it had, it would slurp it down, unpack it. So just anytime I merged something, I knew it was going out. It was boring. It just happened, right? And I don't know if you've ever heard the story about Alexander the Great. The story goes that when Alexander was a young boy, 8 years old, his father gifted him a baby pony and had him pick it up every day before breakfast. So Alexander grew to be an adult, and he could pick up his horse because he started when it was small, right? Obviously, it's a myth. But we grew up that way. We grew up the expectation that your code was going to go out as soon as you merged it. And it's easy. We don't think about it. It just happens.
Very interesting. So given that we're talking about like, okay, you merge it, you ship it, does that mean for continuous deployments and delivery, we need to only be working in trunk-based development?
I maintain that continuous deployment is the goal. I think that the only reason that we said continuous delivery is because this was like 15, 20 years ago. And I think the tooling didn't really exist to do continuous deployment safely. It does now. The only reason to be like, oh, well, you could ship it anymore. Okay, but like the goal is continuous deployment. The
Right.
goal is for a merge to equal a deploy.
That's interesting. What about like trunk-based development? Does it need to be trunk-based development for an organization to succeed with
It kind of
fearless
does.
deployments?
Yeah.
Interesting.
I mean,
Uh,
it's probably technically possible to decouple those, but I've never seen it done.
Interesting. Okay, so let's say kind of like, okay, an organization is bought into. We need to, like, a leader comes in, a new leader comes in an organization. We need to get to continuous deployments. What is needed for an organization? Is there like sort of like a checklist of things that they have to get to before they can turn on continuous deployments?
Oh, there are definitely prerequisites. You have to have a test suite that you trust, right?
Okay.
You have to trust in your tests. And if you don't trust in your tests, then you need to work on your tests, right? You need to be able to you need to take the amount of time it takes to actually build and deploy your code. It needs to be not a long period of time, right? And a lot of this, it's hard to say checklist because so much is dependent on what stack are you using, how big are you, using microservices or a monolith or whatever. But I would certainly don't say turn on continuous deployment if a high percentage of your deploys fail, or if it takes 2 or 3 hours to ship something, right? That's not a state in which it's reasonable to do this. One of the arguments for making it fast too is that a big source of instability is batching up a lot of people's changes at once, right? And so, if you're shipping a change set from 50 different people at once, well, that's much scarier than if you're changing a diff from 1 or 2 people at once, right?
Right.
Um, so, I mean, you got to have deploys that are boring, right? And so it kind of goes hand in hand. I would, and some of this is about your tolerance for risk too. Like if you're a bank, you probably have a different threshold than a 20-person startup who's working on ads or something.
So does that mean like a bank should not strive to get to continuous deployment?
I I think that it's sort of a North Star that is like, it means a lot of things are going well. I have a real hard time with blanket statements. I don't think there's anything that you can say everyone should do this, right?
Right.
But if, just much like Friday deploys, there are lots of really good reasons for people to just be like, we've looked at the pros and the cons and we've decided it's not good for us to deploy on Fridays, right? But I don't think people should pat themselves on the back for it and say, "Yay, us! We care about people, so we don't ship on Friday." I think that's exactly backwards. If you care about your people, then you make sure that they're not getting woken up and called after hours at all times, right? And I think that like looking at why can't we do continuous deployment, that
Mhm.
probably leads you to a list of things that would make everyone's lives and the business significantly better if you fixed them.
Interesting. So there is another part of it, right? If we are doing continuous deployments, no matter how much test we have, there will be scenarios or situations where
Yeah.
things go wrong, where production
Mhm.
breaks. Do you have any thoughts on that? Like, how can an organization, like, I believe this is part technical, part cultural, right? Like,
Yeah.
one is there needs to be, okay, an acceptance that things can possibly go wrong, but at the same time, there could possibly be tooling to reduce the blast radius.
Yeah.
Do you have any thoughts on kind of like what can an organization do? I know this is probably also not maybe a generic answer, but like maybe you can talk about like how Honeycomb
Yeah.
manages this.
I think feature flags are a power tool here. I think not relying on deploys to like turn code on and off, but being able to flip the switch on and off is really powerful. In fact, I think there are probably a lot of questions that I would say the answer to this is probably feature flags and good observability, because the magical thing that feature flags does, and I think I wrote a post about this at one point, is it decouples deploys from releases, right? Because the needs of software teams, the needs of R&D is typically to like ship small diffs, smaller diffs more frequently. Keep the spice must flow, right? Software goes all. But there are other needs of the business. There are marketing needs. There are product needs. There are sales needs. They need to release on a specific day at a specific time and using feature flags to turn on and off bits of code, does this for you. It also can make it so much easier and safer. Yeah, you should have tools that will allow developers to initiate deploys and rollbacks and everything. But what if you don't have to? What if you don't have to like roll the whole code back, right? What if you could just turn it off? I think that's a really powerful tool to have.
Obviously, I'm gonna ask about like things like Canary, blue-green
Canaries,
deployments.
yes. Absolutely. Canaries, progressive deployments in general, right? Comes in a lot of flavors. And again, this is not a cure-all, but there are a lot of different, like at Facebook, we would, like a lot of products got demoed in New Zealand because it was small, it was English speaking, it was, you could kind of fuck it up and, it wouldn't make the news. But then, if it went well, it'd get rolled out, in percentages. And it gets, until it reaches 100%. There's a lot of things about, and if you're using this with observability, like the Ollie 2.0, which is the high cardinality, high dimensionality, the ability to slice and dice, then it's really powerful because, you can, if you roll it out to 1% of your machines, and then you side by side, do the error rates look the same? Does latency look the same? Does, try the feature a few times, does it look the same? That's really good. Up the percentage, right?
Interesting. Okay, so I want to switch topics a little bit. I want to talk about like cultural aspect, or more specifically, the blameless culture. So I talk about that deployments is a little bit of a self-driving car problem. It's like to actually get people to trust that a car these days. Now you have Waymos, right, in San Francisco without a driver, but it took them a long time,
Yeah.
and they always had somebody on the driver's seat. And
Yeah.
part of this, like, if something goes wrong, it's the driver's problem,
And
even if
probably
the
just a
car did something.
vestigial driver.
And I find like, if there is somebody who's actually pressing a button to deploy, leadership feels a little bit more comfort that, okay, okay, it's somebody's problem. They are observing it. They're responsible for managing the deploy. And eventually, sure, you can get to a point where it's like completely continuous and there's no humans involved. But like, I also feel part of the reason many organizations don't get to that is because it's harder for them to do postmortems and blame that, okay, this is the reason why things broke in production.
Well, I feel like ownership is such an important part of software. Just because someone isn't pushing the button doesn't mean a developer shouldn't be aware. Oh, I just merged. Oh, I should keep an eye. I should be watching, right? You don't merge and walk out the door, right? You feel some ownership over what you're putting out into the world, right? And I think that you can instill, like, we've come so far over the past few years in terms of really expecting developers to own their code in production. 10 years ago, I was on Twitter talking about, developers on call, and developers got mad at me. They were like, I didn't become a software engineer to get woken up in the middle of the night. How dare you? And it's like, well, someone's getting woken up in the middle of the night for your shitty code. Like, it's a little bit classist of you, don't you think? Like, I'm getting woken up with your code. And again, I don't think this is a question of like morality so much as it is a question of feedback loops. And having the person who writes the code, the person who's familiar with the code, be the person who responds to it, is a much more effective feedback loop than having half of the engineers write the code and the other half understand and debug and respond to it. And so I feel like it's hard to predict exactly what people are going to be afraid of, but you have to take it seriously, right? And I actually find that the people who are the most fearful tend to be the ones who are not actually directly connected to the technology, but they're the ones who are a step or two away, kind of to your original point, going, but what if no one's watching, right? But tooling plays a really important part in it's like the socio-technical assistant, these are intertwined, right? You build some tooling, you test it, right? You gain some confidence, you gain some trust, and then you have to communicate. You have to pass that trust along, right? We trust this now, so we can build a little bit more tooling. We can move a little bit farther.
Interesting. Yeah. So, based on what you said, does that mean we don't need SREs anymore?
It's not. I think the SRE profession is changing. I think increasingly, we don't have a bunch of people who do infrastructure and people who write. Everybody writes code, and everybody's expected to own the code that they write. SREs are experts in extremely complex systems. And so I see a lot of folks, like our SRE team takes more of a consultative mode, right? They get embedded with different product teams, and they might be in the on-call rotation with them, they might not, but those teams need the operational expertise that SREs bring. But it's not the old kind of SREs where it's like, all right, SREs carry the pager and the software engineers don't. Like, I think we're learning that that's just not an effective model.
And what about, sure, like, I mean, we already discussed production can go down, right? No matter how many,
One other thing I'd
production.
say about this is I really think one of the most interesting things in recent years has been the emergence of platform engineering.
Okay.
And the way I think about platform engineering is it is a team that has a product ethos, a lot of design thinking. Their customers are other engineers internally. So they're building tools that enable and empower feature product teams to own their own software. They're not on call for them. They're not owning it for them, but they're giving them the tools to own it themselves. And I think that is such a successful model. And I think, it's a little bit different from SRE. There's a lot of the same genes involved, but I do see that becoming more common of a model.
I feel like I've done a few podcasts on platform engineering. Almost everyone has a different definition of what it
Yeah,
is.
I know, but mine is the best and correctest.
Yeah, it's like kind of like going all the way from being just rebranding DevOps to kind of
Yeah,
like thinking about like internal tools, like inner loops versus outer loops. And
yeah.
then there is also like about like SREs and yeah, like some, like for instance, if you have Datadog, half of their engineering is platform engineering. And they
What?
say any, like I think about, they have about 1,400 developers and 700 of those are platform engineers.
Okay.
And their point is like anything that doesn't touch customer directly is platform engineering.
Well, that's a definition.
So again, that's what I'm saying. I think platform engineering, many times I have a love-hate relationship with it just because
Yeah.
it's very hard to define it. At least
Well,
very hard to define that everyone would agree with.
that I agree with. But I do think that like bringing a infrastructure has traditionally suffered from a real lack of, we haven't had product managers, we haven't had designers attached, and I think that that's part of the reason that these tools have felt so punishing
Right.
and inhuman. They've been such a priesthood for so long,
Right. Right. And I think like other challenges, it's very hard to standardize that
Yeah.
this is how platform engineering should be across all organizations. It's even hard to standardize within an organization. Okay, so just moving a little bit into the blameless culture. I do want to talk also about like psychological safety, right? We talked about, okay, developers need to take responsibility of things that they break, right? But at the same
Yeah.
time, you don't want to, I mean, this can also introduce the fear that we were talking about before, which is
Yes.
like, okay, if my changes are going to break, maybe I'm going to be scared to even merge my changes, right? Or
Responsibility
maybe,
is not blame, right? It's like ownership is not like blame is when you're like, you should have known better, or how dare you. There's some amount of shame involved in it, right? Like
right,
you should, and that's not helpful. It's not helpful, and it's not. I mean, you can have a conversation with the developer being like, you need to write more tests, right? Which is like, okay, let's just look at we can acknowledge reality
right,
without like naming and shaming people, right? And this is something where I feel like, in general, I'm a pretty bottoms up person, but I think that this is something where it really, the tone is set at the top. And if the person at the top is like looking for scapegoats, there's very little that the rank and file can do to overcome that. So like, they can really make the entire environment unsafe with just one, who did that? It's really hard to recover from that. And so
right.
they really have to be like, I don't know, there isn't like one single solution to this, but they should understand how toxic and damaging that is. But I think one of the things that SREs are really good at is explaining this to the various stakeholders. I think most engineering leaders 20 years ago, all right, I don't know, I was just a baby then, not a baby, but like I was very young in my career then, had a very sort of like clamped down, sort of blamey approach, right? But we have collectively worked our way out of that hole, right? We have learned together that does a lot of damage. It makes people scared to speak up, scared to be like, oh yeah, that was mine, I own that, right? So I don't think that most people are a lost cause, but I do think we need to continue to be vocal about the right socio-technical, path to a better world, and just, politely letting people know, even if they're higher ups, letting
Right.
them know when the way that they're talking is not helpful.
So there's a bit of a process angle to it as well. And I want to understand, like, can process help reduce psychological safety? Like, for instance, one example I'll give you is, how does code reviews play into this process? Like,
Ah,
are there responsibilities from the reviewer? Can an organization enforce certain types of reviews to reduce that risk? Or maybe it's like every time the production goes down, it's not just the responsibility of the developer, but also the reviewer, which I've heard a few times, but it also feels like that's very counterintuitive.
you know, I would be curious to hear from anyone who has done this and found it to be really helpful. My feeling is that the main point of code review is to generate a shared to make sure that at least one other person really knows and has a stake in what's going on, because so far, and AI may change all this, but like the real product of any software engineering team is shared ownership, shared understanding of a corpus of work, and if only one person understands it and has any knowledge, well, someone else is gonna have to learn at some point, and will probably be less ideal circumstances, right? So like I also feel like just the act of having to talk through what you're doing, the choices that you've made, typically makes you find a lot of problems in your own shit that you otherwise might not have if you were just like, done, merge it. Right. And honestly, I think that's probably most. I don't know that I love the idea of being like, all right, we blame you too as the reviewer. Um, I don't know. I'm curious. What do you think?
I mean, honestly, like, I have written a lot about code reviews, and for me, I think it resonates a lot with what you're saying. Is like code reviews are a lot about knowledge sharing and avoiding sort of like these gaps that you have in organizations where very limited people have understanding. In fact, we even have a product called Flex Review, where it's like, how do we expand the knowledge sharing and not
Yeah.
have like very static ownerships?
Yeah.
So we create like models around that. So we try to push organizations a lot more for like, okay, yes, I understand there are certain aspects which are more secure. Like if you're Stripe, you're like some of the system you're building in Vault, that's probably like something
Yeah.
you want to be double sure of and have certain people who are like reviewing it. But actually, I remember speaking with Scott McVicar a long time ago, and he said they don't have very clear ownership across entire organization. Maybe some parts they do, but like rest of it, anybody can approve anything,
Yeah.
right? So I think it goes a lot to say that yes, there has to be a shared ownership. There is still obviously people working on different code bases, but like one of the things I liked about Google was also how easy is it for one person to move from one team to another.
Yeah.
And the way they can do
Yeah.
that is because many of these systems are built in a very similar way and the ownership is shared and defined.
It's also a really important, I think, pedagogue teaching tool, learning tool. Just like talking through your choices. Like if you're reviewing with, if you're doing a code review with someone who is more senior than you or knows more about, query smithing than you or something, I think it's one of the most important ways that we learn from each other.
Right. Right. And also, like, yeah, for instance, I remember in certain organizations I've been part of, like, when I joined the company as a senior engineer, they will assign reviews to me. Is like, hey, what do you think about that? Because you're bringing in fresh perspectives,
Yeah.
right? Some things that we may have blind spots to. And I think those are also really powerful ways to kind of like
Yeah.
just have that unified mindset and mentality.
Generative culture.
Right. Okay. So let's talk a little bit about identifying when things are not going right. Going back to the deployment spot, right? Let's say there's an organization which deploys maybe once a month, but like every time the deploys goes out, nothing breaks. Do they have a deployment problem?
I don't know. Do they? I mean, if I mean, it really depends if they are meeting all of their business goals
Mhm.
and nothing ever breaks, and their engineers are moving as fast as they need to move. Then no, I don't think they have a problem. You know, um, I would be interested to know what industry that is in.
I mean, back in the days when you used to ship software on CD, that was very common.
Yeah, no, for sure. That's true. Uh, yeah, and so like it is a big world out there. There is a rainbow. I just somewhat recently, I was hearing about somebody who showed up at like an SRECon observability thing, and they were like, "Oh yeah, we spend no money on instrumentation or observability. Nobody's on call. Our customers let us know when something breaks, and we're fine with that." And I'm just like, okay, I mean, good for you, good for you. I if you're happy, I'm happy. It 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 makes me wonder about how reliable the narrator is, but I assume that they know what they're talking. I assume that's fine. I mean, if they're happy, I'm happy. I guess I yeah. I just think that for most of us,
Hmm.
the world moves a bit faster than that, and a lot of things change over the span of a single month. And so doing a monthly deploy is not going to be a happy experience.
Interesting. And like, let's imagine kind of like, you talk to an organization, they're trying to figure out like, we don't know how our deployments are, right? Um, what kind of questions would you ask them, or like what kind of things you would ask them to introspect to know that they have a delivery problem?
I would ask who's on call. And then I'd want to talk to those folks. Like, what is your life like? Right? And that's where I would start, which is maybe my ops roots betraying me, right? But this is also a business problem, right? Like, are your customers happy? Are they? Are you meeting your revenue targets? Are your investors? It's like all the way down. Like, if everyone's happy with what you're doing, then there's no reason for me to be unhappy. But typically, if there's someone who's not happy, I think that's where you find the thread and you start pulling on it. And at the bottom of most tangled threads is shipping software is hard and flaky and takes forever, and someone's getting really burnt out.
Interesting. Okay, so just kind of like double clicking on that. Like, imagine that you were hired by an
Another thing that I
organization.
will mention is, like, I don't know if you've ever say found a cool mobile app and you're like, and you look the company up and go, oh, they have 800 developers building this, and you're just like, what? I think that when deploys are slow and flaky, it I've referred to this at times as the software engineering death spiral, where everything kind of takes forever. So people have to context switch a lot. They're spending a lot of time waiting on each other. Things are backing up, so they can't move very fast. And so part of what happens is they have to hire more people. They start
Hmm.
hiring SREs, and they hire release engineers, and they hire more PMs and more managers, and more and more and more people to do the same amount of work. And everyone's stressed, everyone's busy, everybody thinks they need more people because they're so busy and stressed. But like, the problem is a systemic one, and they can't actually fix it. They cannot hire their way out of that problem. In fact, the more people that they add to this twisted, like, just like this bird's nest, the hairball that the cat coughed up, it's under the bed, the worse it's going to get, right? And the only way you can fix it is to start to fix the systems of it. And you
Hmm.
should need fewer people to build something like that. So that's also a failure case that I see a lot.
Interesting. So I'm going to just double click on this. Imagine this is the organization that maybe hired you for 1 month to fix the problem. What would you do?
I What would I fix it in a month? Goodness, they have high expectations, don't they?
Or give them a plan or a roadmap to fix
The
it, I suppose.
plan. I wouldn't want to just jump to the conclusion that the problem is a delivery pipeline, because there could be other problems. It could be that their management sucks. It could be that the requirements they get keep on changing. But let's say that, all right, let's put that aside and let's say we figured out, oh, the delivery pipeline is just a mess, right? I think the first thing that I would advise them to do is instrument their CI/CD pipeline using observability, like a trace, right? So you can because this is not a hard problem. This is just engineering, right? It's just bringing the amount of time that it takes to like run your tests and deploy your software is just engineering. If you can see where the time is going, you can start parallelizing. You can start getting rid of flaky. Just bring that amount of time down. I would also, obviously, I work for an observability company, but like, you can't fix what you can't see, and so often I feel like this is like the dark matter of software engineering is the poor observability. You can't see it. All you can see is the problems and the flakes and the things that your time is built. But if you can see it, then you can fix it. So I would advise them to put good granular observability around anything that is under active development, anything that is revenue facing, customer facing, revenue impacting, the stuff that's changing a lot or the stuff that makes money for you. You should be able, so much of the fear on deploys comes from that, oh shit, it broke. And then it takes them an unbounded amount of time to figure out what it was because they're trying to figure it out by reading lines of code or something like that, right? And you should be able to slice and dice just, and this is, I got religion on this at Facebook, right? Like, because trying to figure out why parse was going down every day, something different, and realizing that you can't do it without high cardinality, high dimensionality, all this. But if you can go, okay, we just deployed this diff, slice and dice, boop, it's this, it's this, it's this. If you have confidence that you can figure out the root cause swiftly, yeah, those are the things I would start at. Bring down the time to ship. Add a lot of observability. Spend some time training and up-leveling people's skills when it comes to navigating production in general. Add feature flags. Add, guardrails around your deployment process. And little things, even like trying to close feedback loops by, if you're deploying several times a day to, and a small number of diffs are going out, and if something goes red, like right after deploy, drop a Slack message to the few set of developers who had a change that just went out, right? This is about feedback loops, right? So anytime you can shorten those feedback loops, the whole org benefits.
That's very cool. Okay, so I know we are at time, but I would want to obviously ask this question, which is like, you can't do a podcast these days without AI. So what is going to change with AI, both in observability and in deployments?
Oh, yes. I'm so glad you asked. First of all, I think that all the things that we've been saying, ironically, for years about Observability 2.0, about how so many things about, first of all, I think you can't have good observability for AI unless it's embedded in good software observability. You can't just like understand your model in isolation, right? Secondly, these are trace-shaped problems. From the moment that you gather your inputs to, it executes the software, it calls out to various APIs, data storage systems, calls to your model, all the way to the point where your user gives you feedback on that is one big trace-shaped problem. High cardinality matters more than ever. Context matters more than ever. I feel really strongly that that's really going to be important. But I also feel like instrumentation should get easier, because we should be able to go like, hey, Claude, get me traces, right? Auto instrumentation should get a lot more specific. AI is good at the ingestion part. It's good at the cost saving part. It's good at the anomaly detection part. It's good at, I think that there are just a lot. I think we're going to move away from static dashboards and much more towards workflows. I also think that the entire industry is realizing that in order to build good AI software, tight feedback loops are a necessity, which is exciting to me because I feel like there are so many things that are moving the industry slowly, painfully in the direction of shorter feedback loops, tighter deploy cycles, and doing your work in production, because you can't like train your AI in staging and then release it to production. It doesn't work that way. You work on it in production, right? So I'm excited.
Amazing. Maybe I think we need to do another podcast in 6 months and see how these things are evolving. Just because, like, I feel like I used to say like a year or two, but like things are moving so fast that it's like, things like literally every week, every month we see new things.
And then after that, part 3 will be 6 weeks later, and part 4 will be 6 days later.
Love it. All right, Charity, I have taken more time than I should have. Thank you so much for this time.
This
This
really
was lovely.
fun. Thanks for having me.
Yeah. I'm glad you were able to make it. So thank you so much. Have a good day.
Thanks. You too.
Bye.